The question we are solving now belongs to test series 1. It is of signals and system subject. In specific, it belongs to basics of signals. As per the question, there were 4 options given: A, B, C and D. We need to find which of the options corresponds to Fourier series expansion of a periodic signal. The option A contains cos t plus sin t plus sin root 2t. The option B contains cos t plus sin root 3t plus cos 2t. The option C contains cos of pi t plus cos of 2 pi t plus sin of pi t plus sin of 50 pi t. The option D contains cos of root 3t plus sin of 5t. We know that from the alternate Fourier series expansion of a periodic signal, which is periodic with a period of 2t, the Fourier series expansion looks like f of t is equal to a0 by 2 sigma n equal to 1 to infinity an cos omega nt plus sigma n equal to 1 to infinity bn sin omega nt. Please note that here omega n is equal to 2n pi divided by 2t, that is equal to n pi by t. From this we see that if we pick any two terms corresponding to the Fourier series expansion of f of t, the ratio of the frequencies, that is omega m divided by omega n, is equal to m by n. As m and n are integers, the ratio of the frequencies should be rational. So one of the important properties to note here is that the Fourier series expansion contains many terms, and if we pick the frequencies corresponding to the harmonics, the ratio of these two frequencies should be rational. So if we pick the option A, here we see that the harmonics correspond to the frequencies of 1 and root 2 radians per second, and the ratio of the same is not rational. Hence, the option A is not a Fourier series expansion. Similarly, if we pick option B, the option B contains the harmonics at 1, root 3 and 2 radians per second. Here also we see that the ratio of any two ratio of frequencies of any two harmonics is not rational, hence B is also not a Fourier series expansion. Whereas in C, the harmonics are at a frequencies of pi, 2 pi and 50 pi, and we see that ratio of any two of these frequencies is rational. Hence, C can be the Fourier series expansion of a periodic signal. We see that in case of D also, the function written is not a Fourier series expansion, as the ratio of the frequencies of the harmonics is not rational. From this, we see that the signal given in option C can be the Fourier series expansion of a periodic signal, as the ratio of any two angular frequencies is rational. So the correct option is C.